Hello grade 9, welcome to yet another video in maths, and today I'm focusing on maths paper 2, and a concept or a subtopic in maths paper 2 that I want to look at is called Pythagoras Theorem. So we just want to look at the statement and what it really means, and then we'll look at applications of Pythagoras Theorem. So grade 9, maths paper 2, let's call it a topic that we want to focus on is Pythagoras theorem. I'll come again with yet another video where I'll be looking at congruency, similarity, and all other aspects of maths paper 2. So what does Pythagoras theorem state? So let's look at the statement there. Statement. It says in a right angle triangle, the square of the hypotenuse is equal to the sum of the squares the other two sides. So it says in a right angle triangle, the square of the hypotenuse, let me remove this, I don't want it to look like one word here. In a right angle triangle, the square of the hypotenuse is equal to the sum of squares or sum of the squares of the other two sides. So let's look at the right angle triangle then. This is our right angle triangle. What does Pythagoras theorem say? Firstly, which side is hypotenuse here? It is the side opposite the right angle. So that would be our hypotenuse. So it says the square of the hypotenuse is equal to the sum of the squares of the other two sides. So if this triangle is A, B, C, Pythagoras theorem is saying basically that AC squared is equal to AB squared plus BC squared. Now proof of this is done by using many other tricks. In grade 12 we prove this by using similarity, but in grade 10 it's proved by using congruency. In grade 9 we state it without proving it because the syllabus does not require us to prove it in grade 9. So in a right angle triangle, the square of the hypotenuse is equal to the sum of squares of the other two sides, or sum of the squares of the other two sides. This is what it says. Now, please take note of how this is stated here. It is the longer side. When you square the longer side, the answer will be the sum of the squares of the other two shorter sides. In other words, the two sides that make up the right angle. When you square them, it will give you the square of the longest side in your right angled triangle. So the triangle has to be right angled. We will look at the converse of this at a later stage, but for now, let's look at examples on application of this. So straight into examples. This is going to be a very short video. Number one, suppose you're given a triangle that looks like this, and you're told that this angle is 90. This is triangle LMN, and you're told this is 6 centimeters, and you're told this is 8 centimeters. The question is calculate the length of ln. Now, how do we answer this question? So let's call this page 1. And I move straight to page 2. Maintaining this one here. Maintaining this. So you can see where I'm coming from. That's our triangle. And I'm going to redraw it on my solution page, page 2. Page 2. The answer, if I redraw the triangle, it looked like this. We had 6, here it is, 6 centimeters LM and 8 centimeters there MN. So 6 centimeters LM, LM, N, and this is 8 centimeters. So your answer will be LM. Let's start with LN. LN, the square of the hypotenuse, is equal to the sum of the squares of the other two sides. Do not forget to write Pythagoras theorem. Take note of the short form that I'm using there for Pythagoras theorem. Py, capital Pyth dot THM dot. So that's Pythagoras theorem in short. Let's put in what we know. What is LM? It's 6 and we square it. Plus, what is MN? It's 8 and we square it. If you square 6, you're going to get 36. If you square 8, you're going to get 64. When you add these two up, you get 100. What are we saying? We're saying ln squared equals 100. And to solve this equation, we have to do the opposite of squaring, which is taking square root. So we're going to say, therefore, square root of ln squared is equal to, remember we're dealing with distance, so we don't have to put plus or minus here now. Square root of 100. Distance is always positive. So this cancels that. Therefore, our ln is going to be equal to square root of 100 is 10 centimeters. This is calculating the hypotenuse in example number 1. I want to move to example number 2, where you are supposed to calculate one of the two sides. Right, example number 1. Let's go to example number 2. This should be page 3. Page 3. Example number 2. Suppose you're given a right angle triangle that looks like so. You're told this is R, ST, and this is 13 meters, and this is, let's say, 12 meters. The question is calculate ST. Calculate the length of ST. In order to do that, we have to recognize the fact that the triangle is right angled, and therefore we can apply Pythagoras theorem. Remember, Pythagoras theorem is applied when you have a right angled triangle and two sides are given. You're supposed to work out the other side. Now, our solution here, or answer, is going to be as follows. Remember, the square of the hypotenuse, SR squared, is equal to the sum of the squares of the other two sides. So SR squared equals ST squared plus RT squared. Do not forget to say Pythagoras theorem like so as your reason for that statement. Let's put in what we know. This time SR is known, so it's 13. We're squaring it. Do we know ST? No, they want us to find it. Plus, do we know RT? Yes, RT is 12 meters. We're squaring it. What is 13 squared? 169. ST squared. Plus, what is 12 squared? 144. Now, how do we solve this equation? Well, this equation, you can rewrite it as ST squared plus 144 is equal to 169. You're just changing sides there. Now you can take 144 to the other side. You're going to get ST squared equals 169, 144 there, it will become minus. And therefore ST squared is equal to this. If you subtract 144 from 169, you're going to get 25. And again, we've arrived at that stage. Which stage? At this stage where we take square root both sides. So we're going to take square root both sides here. So therefore, square root of ST squared is equal to square root of 25. And this cancels. And therefore, ST equals, what is square root of 25? 5. But it has to be in meters. Remember to respect the units they have given you. So length of ST is 5 meters. Right. This is calculating one of the sides. Now, I want to put up example number 3, where the angle is not given, but you're given all the sides, and then you are supposed to determine whether the triangle is right angled or not, which is some sort of what we call the converse or the opposite of Pythagoras theorem. Let's look at, this is page 3. Let's look at page 4 now. So I'm going to put it at the top here, converse of Pythagoras theorem. Converse is opposite. Now, let's look at an example here. I want to cover this by means of an example, and then I'll generalize at the end. So, suppose I'm given a triangle that looks like this. They tell me that this is 5 centimeters, and they tell me that this is 3 centimeters, and they tell me that this is 4 centimeters. This is triangle A, B, C. The question is, prove that triangle ABC is right angled at C, i.e., in other words, you're supposed to prove that angle C is equal to 90 degrees. Now, how do you prove this? Well, simple. Proof, we do the opposite of Pythagoras theorem. So we're going to say the longest side here is 5. We take AB, we square it. The answer is going to be 5. Forget about the units, squared. And this is 25. And then talk about AB, AC squared plus BC squared. AC squared plus BC squared. What is this equal to? AC squared would be 4 squared plus, what is BC? It would be 3. And we're squaring this. Now, if you simplify this, this is going to be 16 plus 9. What is 16 plus 9? 25. And you see that this number is equal to that number. Your conclusion is, therefore, AB squared is equal to AC squared plus BC squared. And then you say, therefore, what are we going to say as our conclusion? Angle C is equal to 90 degrees. Why? Converse of Pythagoras theorem. Please take note of this. There it is, converse of Pythagoras theorem. This is how you prove it at grade 9 level. This is how you prove it. If the longest side squared is equal to the sum of the other two sides squared, it means that the triangle is right angled and the longest side is your hypotenuse. So this would be your conclusion, which actually proves what they're requiring us to prove. All right, now this in short is what Pythagoras theorem is all about. Now, what examiners like to do, and this is critical now, what examiners like to do, I'll bring it up in my next video, where I'll be looking at 2023 end of year paper 2 exam for grade 9. What examiners like to do is they say, for example, they'll tell you there is your circle, and they tell you this is x-axis, y-axis, and they tell you that this distance here, obviously we know is radius, and they tell you that is in the y direction, so let's call it y. That angle is 90 degrees. Let's call this distance from here to there x. And then they say x squared plus y squared equals r squared. Why is this the case? Give a reason for that. Pythagoras theorem. Let's look at a typical exam question, and this is where I'm going to stop. Typical exam question. Typical exam question. I'm gonna take it from the 2023. This was multiple choice question 1.3. Multiple choice 1.3. I'm gonna copy it here. 2023 paper 2. This is a Kuleni North, which is D6 in Gauteng, South Africa. The question was, so that's question number 1.3 on multiple choice, question 1.3. Look at the question here. It says this is the triangle. They have called it triangle A, B, C. And they are saying this is B, and they are saying this is C, and they are saying this is A. Those are sides. And then they say the length of AC is, the length of AC is, now length of AC, your hypotenuse. Remember what we say, the square of the hypotenuse, which is now in this case they have given us a small letter b, must be equal to the sum of the squares of the other two sides. Now this b squared is not length of AC. Length of AC is found when you take square root both sides, remember? The examples I've given you so far. So you're going to say, therefore, square root of b squared is equal to, remember we're dealing with distance, square root of a squared plus c squared. What is this? Your b is going to be equal to square root of a squared plus c squared. Now, they have given options here. They have given options. Let's check A. They say the answer is a squared plus b squared. B, they say the answer is a squared plus c squared. And then C, they say the answer is square root of a squared plus b squared. And then they say D is square root of a squared plus c squared. Now you can clearly see that the correct answer is D, because that's what we found it here. That's what we found there. So that is our correct option for the length of AC. These others are not correct options. All right, I'm going to stop here in this video, and I'm going to come back with another video, not to deal with Pythagoras theorem anymore, but I'm going to be dealing with congruency, and then another video with similarity, and then we'll be looking at calculating angles. Right, if you're new to this channel, please subscribe. Let's share these videos. Like these videos, it will give us the, like I always say, the impotence or the momentum for us to generate and produce more videos, hoping that will make a difference in somebody's academic life. Thank you very much.